Welcome to my algebra class. We're on Chapter 5, Section 10, Factoring by Grouping. We're skipping 5-9 until after this because to do 5-9 we need to know how to do it by grouping. Now remember, factoring involves multiplication. Everything that you end up with has to be multiplied. So we need to be sure that all our addition symbols are not included in parentheses. So in these examples here, we're going to use a distributive property to factor. So I can see that m plus n is my candy. So I take it out, keep the parentheses, and in parentheses I put down the first thing it was used with. Always keep your order correct. And the last thing. And there I factored it. It's that simple. The next example, the y minus z and the y minus c are the candy. They were used twice. My common factor, pull it out. In parentheses, it was first used with x and then minus 3. Now the second set of problems here, the m minus 2 is not the same as 2 minus m. But if I look at the two of them, they are identical, except their signs are different. This is positive, this is negative, this is negative, this is positive. So if I took out a negative 1, this would become negative 2 plus m. Because if I multiply, I get 2 minus m, which is the same as this. So that's what we're going to do. And we're going to take it out of the second one, just because it makes it a little bit easier later. So these are the same if I pull out a negative 1. So I'm going to take 7 times m minus 2. If I take out a negative 1, this becomes positive 5a times, and I turn it around and make it look like the first one, m minus 2. You just have to be absolutely sure these two are exact opposites. So now I can take out the m minus 2, and in parentheses put 7 plus 5a. Second example, I have y minus 3 and 3 minus y. The y's are opposites, the 3's are opposites, so I can take out a negative 1. If I do, that becomes positive. Negative 1 times negative 2 becomes positive 2. And then turn that around, y minus 3. So y minus 3 has been distributed, take it out. And in parentheses, it was first used with 3y. And then plus 2. Now, if a polynomial has 4 terms, look for a way to group the terms in pairs. This is like after FOIL when you get the 4 products, kind of like working backwards to find the factors. So I'm just going to automatically pair these two together and these two together. Now, I'm looking for a common factor, which I can see is b. I'm going to pull it out. You have to pull out your greatest common factor. And it was first used with a and then a minus 2. Now I want this is the critical thing here. This has to show up here. For this to be factorable, it has to show up here. And I always check my signs because I don't want opposites here. I want to take care of it immediately. So this was positive, negative, this is positive, negative, so I'm going to pull out a positive. The signs are the same. And I can see the c is used twice, so I'm going to take it out, and in parentheses I have a first minus 2. And you see we got the same factor. So now I can take that out and in parentheses put the b plus c. Critical thing to remember is that this factor and this one here have to be the same. And that's why you check the signs and make sure you pull out a negative if you need to. Okay, the second example, I'm going to pair these two together and these two together. The greatest common factor I can pull out is p squared. So in parentheses, I need a p to get back to p cubed and a negative 3. Now remember, this one has to show up here. So I check my signs, positive, negative, negative. I pull out a positive, and the greatest common factor is a 2. And I need a p minus 3. So it has to show up. So p minus 3 is my factor that's distributed. It's first used with p squared and then plus 2. I put down the vocabulary for you. If you want to copy it down now, you can. Just pause the video. Open your books to page 225. Head your paper, skip a line, and you have the title, page 225, written 1 to 38. Problem number 2, copy it. It's 7 times r minus s plus t times r minus s. I can see r minus s is my common factor. I pull it out. It was first used with 7 and then with plus t. Number 4, copy it down. It's w times x minus y minus 8 times x minus y. These two factors are identical, so you can take them out. And it was first used with w and then a minus 8. Number 6, I have 7 times m minus n plus p times n minus m. Okay, the factors are not the same, so I'm going to see if they're opposites. M and negative m are opposites. Negative n and n are opposites. So I can take out a negative 1. So I rewrite it 7 times m minus n minus p. So I had to take out the negative 1. And then I'm going to rewrite the second one just like the first one, m minus n. So my common factor is m minus n times 7 minus p. Don't ever change the order for the second one. It's how they appear in your problem. Number 8, you have u times v minus 2 plus 2 times 2 minus v. Again, these two are different. Check the signs, v, negative 2, 2. So I can take out a negative 1. So I have u times v minus 2 times, and I'm going to rewrite this like the first one, v minus 2. So my common factor is v minus 2 times u minus 2. Problem 10, I have 3p times 2q minus p minus 2q times p minus 2q. Check, they're not the same, so check your signs. 2q and negative 2q, negative p and p. So I can take out a negative 1. If I do, this becomes positive 2q. So rewriting it, 3p times 2q minus p plus 2q, and rewrite the second one just like the first, 2q minus p. Common factor is 2q minus p, first used with 3p, and then with the plus 2q. Problem number 12, we have a times a minus b plus 4b times a minus b minus a times a minus b. So the a minus b was used 3 times. So pull it out. It was first used with the a, then with the 4b plus 4b, and then the minus a. Now we have to simplify our factors, and we can see that a minus a, those are going to go out. So our factors are a minus b times 4b. And the book generally rewrites it so the monomial is first, but we're okay for now. 14, we have r times r minus s minus 2t plus s times r minus s minus 2t. The trinomials are identical, so we take them out by the distributive property. It's your common factor, the candy. It was first used with an r and then with a plus s. And that's our answer. 16, we have x squared minus xy plus x minus the quantity y minus x minus 1. Well, this looks like it doesn't make any sense at all. However, if you look at the trinomial, there is a common factor that needs to be taken out, needs to be factored. So take out the x and we have x squared. Excuse me. We don't have x squared. We have x minus y plus 1. And what's understood to be here is a minus 1 out in front, because we need something there. So if I look at it, the x's are opposites, the y's are opposites, and the 1's are opposites. So if I take out a negative 1, then I have x times x minus y plus 1. A negative 1 times the negative 1 is going to be a positive 1 there. And then I can just rewrite this the same as the first trinomial. So my common factor is x minus y plus 1. Let's first use with x and then with plus 1. And again, the book would probably put the binomial first, but it is okay to write it that way. 18, we have 9p minus 3pq plus 2nq minus 6n. So we need to see, we can see there's no common factor, so simplify. Take out your greatest common factor here, so this would be p, 3p, times 3 minus, and we need a q to get back to that. And here we can take out a 2 and an n. So take out the 2 and the n, and we have q minus 3. And then we look and we see the 3 minus q and the q minus 3 are not the same. However, they're exact opposite signs. So we'll take out a negative here. So we have negative 1. We'll take out 3p times 3 minus q. The negative 1 times the positive 2 would be negative 2n. We can turn this one around to make it look like the first one now. 3 minus q. So our factors are 3 minus q. And it was first years with 3p and then minus 2n. And problem 20 on this page, you have p squared minus 2pq minus 2 times 2qr minus pr. And the first one we can take out a p. So we have p minus 2q. And the second one we can take out the r. So we have negative 2r times 2q minus p. Again, they're not the same. However, they're opposite signs. So we can take out a negative 1. So we have p times p minus 2q. Negative 1 times negative 2 is positive 2r. Now turn the second factor around so it looks like the first. Since we took out the negative 1, we can do that. So our common factor is p minus 2q. And it was first used with p and then with plus 2r. Okay, on page 226, we're doing the problems that have 4 terms, and we're going to do it by grouping. And actually, what we're doing here is, this is the product of FOIL, where we get the 4 terms, so we're just going backwards and trying to find the original 2 factors. So group the first 2, group the second 2, take out your greatest common factor, which is r, and that has s plus 5. Now remember I said it was critical that you watch your signs here, check and make sure they're the same sign so we don't have to pull out a negative sign later. And we should be getting this factor here. Take out, it's positive, 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 positive. So take out a positive t, and we have s plus 5 left. It has to come out to be the same. So our common factor is s plus 5, and it was first used with r and then with plus t. (24), you have u squared minus 2u plus uv minus 2v. Grouping the first two and the second two. Take out your greatest common factor, which is u. That leaves you u minus 2. Check your signs, positive, negative, so we can take out a positive, and the common factor, the greatest common factor is v. That leaves us u minus 2, which we have to have. They have to be the same. So we can take out the u minus 2, the common factor. It was first used with u and then with plus v. And you can multiply them and use FOIL and you'll get your 4 terms. There's u squared plus uv minus 2u minus 2v. 26. We have x squared minus 2xy plus 4xz minus 8yz. Pairing them up, from the first, the greatest common factor is x, so that leaves us x minus 2y. Checking signs, positive, negative, negative. Take out a positive, the greatest common factor would be 4 and a z, and that leaves us x minus 2y. And again, they're identical. If they're not, then you haven't taken out the greatest common factor. So I can take out my common factor, x minus 2y, and it was first used with x and then with plus 4z. Problem 28, we have 3a cubed plus a squared plus 6a plus 2. Pairing the first two and then the second two. Greatest common factor here would be the a squared. And that would leave me 3a for the first term plus 1 for the second. You always have to, if you don't have anything left, it's got to be a 1. Checking the signs, positive, 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 positive. The most I can take out, the greatest common factor for the second pair is a 2. So that leaves me 3a plus 1. And they're identical, so I know I did it right. So my common factor is 3a plus 1. It was first used with a squared and then with positive 2. Problem 30, u squared minus 3uv minus 6uw plus 18vw. Pair them up, group them. From the first pair, the most I can take out is a u, so it'd be u minus 3v. Checking signs, positive, negative. This is negative, positive. So to avoid pulling out a negative and having these binomials be opposite, take out the negative now. So the most I can take out is a 6 and of w. So that would leave me a u and minus 3v. Now you might be wondering, where'd she get the 3v at? Well, a negative 6 times a negative 3 makes positive 18, and I already know that these two have to be identical, so I can just write that one down and double check and make sure it works. So if I multiply, I get negative 6uw, which is correct, and a positive 18vw. So knowing that this has to be the same as this helps you figure out what you need here. So my common factor is u minus 3v. I have to have that common factor, and it was used first with u and then with a negative 6w. 32, we have 3ab minus b minus 4 plus 12a. Group the first two, group the second two. So from the first I can take out a b, and that leaves me 3a minus 1. Checking the signs, positive, negative, negative, positive. I know I have to take out a negative, and it looks like it's going to be a 4. So the only number I can put here is a 1. Doesn't seem to have helped us this time, does it? And this is going to be negative 3a. Well, in a sense, it's like I contradicted myself. But anyway, we're going to continue. These two are opposites, so that's going to be rewritten b times 3a minus 1. And to get these two to be the same, they're opposites, I need to take out a negative 1, so that makes positive 4 times 3a minus 1. So our common factor is 3a minus 1 and b plus 4. But still, if you hadn't taken out that negative sign, they would have been backwards, and you still would have been pulling it out twice. (34). We have 3u cubed minus u squared minus 9u plus 3. Grouping, grouping. Take out u squared, and you have 3u minus 1. Signs are opposites, positive, negative, negative, positive. Take out a negative 3, and you have 3u minus 1. And you can check that's negative 9u plus 3. So they are the same. So 3u minus 1 times u squared. First use with u squared, then minus 3. 36. You have a squared b squared plus 2a squared minus the quantity 2a squared ab squared plus 4a. I would go ahead and drop the parentheses so we can group. In order to drop the second pair of parentheses, you have to distribute the negative sign, so it'd be negative 2ab squared minus 4a. From the first pair of grouping, we can take out an a squared, and that leaves us b squared plus 2. The signs are opposite, so we need to take out a negative 2a, and that leaves us b squared plus 2. And I can check that's negative 2ab squared minus 4a. So our factors are b squared plus 2 and a squared minus 2a. Now we're done if everything's completely factored. I don't have anything left that I can pull out, however I do. This a squared minus 2a, I can take out an a, and I have a minus 2 left. And always, if you get a situation like that, it's always best to put your monomial first, so you don't lose it. And there's our answer. And the last one, 38. We have n cubed plus 2n squared minus 4n minus 8. Grouping, take out an n squared from the first pair, and we have n plus 2. The signs are opposite, positive, positive, negative, negative. Take out a negative 4, and we should have n plus 2. And we do. We can check it's negative 4n minus 8. So our common factor is n plus 2, and it was used first with n squared minus 4. Now here's where math always throws the extra little thing at you. You're done if everything's prime. I can't factor n plus 2, but I can definitely factor n squared minus 4. It is the difference of two squares. So I bring down the n plus 2, and I factor n squared minus 4. It goes to n minus 2 and n plus 2. So watch out for 37, and watch out for 35. They'll probably have something similar to 36 and 38. That's the end of the evens. Check your answers in the back of the